Everyone. In this video, we are going to learn about basic proportionality theorem. Before we are starting the basic proportionality theorem, we are going to learn about few things. Those are first one. If you take a triangle, in triangle ABC, I consider. So triangle have three sides. We can consider any side as a base. So for considering the base, we have the three possibility. One is AB, BC, AC. In these three, we can take it any one of the side as a base. For example, if I consider BC is a base, then the BC corresponding height is AD. This is the AD base of, if the BC is a base, then the height of the triangle will be AD. So, for example, another case we will check it. If AB is a base, then don't consider AD is the height. AB is a base means AD is not a height of the triangle. Then corresponding height we need to take, that is its opposite vertex to the perpendicular distance between opposite vertex to its side. So, for example, if I give this is some CE. So if AB is a base, then CE is its height. Then same way, if I take AC is the base of the triangle. Now, which is the height means AC opposite vertex will be B. So the height should be from B to AC, the perpendicular distance. So this BF is the height when, if we consider AC is the base of the triangle, its corresponding height will be BF. Clear this point? So what I'm going to tell here, in this triangle have three sides, we can consider any one of the side as a base. If we consider BC as a base, and I'm going to write here base and height. Base, its corresponding height. Base and height. If you consider BC as a base, then its height will be AD. Height is AD. Similarly, AB is base. AB is base. Then what is its height, ma? If AB is base, height will be CE. Then if AC is the base, then what is its height? The height is BF. The height is BF. But if anything we can consider, anything means any this possibility, either BCAD combination or ABCE, or if you go for the another thing, the last AC and BF. Finally, we'll get area of the triangle will be same only. So what is the area of the triangle formula? Area of triangle. Triangle area will be half into base into height. Half into base into height. So already we discussed it here, the base and its corresponding height. We need to consider it that way only. Don't take BC base, then height will be some BF or CE means we will get the wrong only. That is not a correct way. So this is in case of acute angle triangle. Clear. In case, if we go with another possibility, in case of obtuse angle triangle, then what we need? Obtuse angle. Obtuse angle triangle. This is obtuse angle triangle. I'm going to take it some P, Q, R. This is the obtuse angle. Obtuse means more than 90 degrees. Now, already we discussed, the above, the same case here. Here also three possibilities we have because three sides are there. Any side we can consider the base. Now I'm going to consider QR is the base. Which is base? The base will be QR. Now what is the height? Height. How to consider the height? I think some of the students you know very well. Those who are have doubt, for them only I'm going to give the clarity on here. So if you want to find the height, we need to extend this QR side. Yes, we can produce like this. And the QR opposite vertex will be the P. From the P point to on QR, draw one perpendicular line. Then this is give some name as some PS. So PS is the height of the triangle. PS is height of the triangle. If you consider QR as a base, then which is its height? PS is the height. So you maybe have a confusion. Sir, we need to discuss for the basic proportionality theorem. What are the requirements for this everything? Means definitely what I'm going to explain here that everything is there in basic proportionality theorem proof. So before if I gave the clarity on this, how to take height of a obtuse angle triangle, what is the base, height, this clarity, we can easily understood the basic proportionality theorem. Clear? Now, here we require one more point also. What is that point means? If we consider two parallel lines, if we have two parallel lines will be there. For example, this is one line, parallel line, some L, and L is parallel to some another line. It is some, okay, take it some P line. These two are parallel. Here I am going to construct a triangle. Here I am going to construct a triangle like this. Okay, this is the triangle. Okay, this is one triangle. So 1 second, I will draw neatly this one. I will draw with a different color. Then we can understand easily. This is the triangle. Okay, uh, this parallel in little bit. So a little bit down. Okay, and one more triangle. This is A, for example. It is B. This is the C triangle. And one more triangle I'm going to write ABD triangle. Okay, ABD triangle. This is ABD triangle. ABD triangle. Just carefully we can observe here ABC triangle, triangle ABC, and triangle ABD, ABC triangle and ABD triangle. I will shade it here. This is ABC triangle, ABC triangle, and this is ABD triangle. Just observe here the careful, the shaded part. And what do you observe here? For these two triangles, AB is the common side. Correct? For these two triangles, AB is the common side. AB is the common side. It means same side. Or we can consider same base. Okay. AB is the same side or common side. Anything we can take it. Common side. And these two triangles, ABC triangle and ABD triangle, lie between same parallels. Same parallel lines. Same parallels. Then we know that the distance between the parallel lines, the distance between the parallel lines is always constant. So base is same, height is same. Then area of the triangles is also same. Area of the triangles is also same. So area of triangle ABC is equal to area of triangle ABD. This is the point When two triangles having the same side, the triangles are there in the between the same parallels, we can say that the area of the two triangles will be equal. They are consisting equal in areas. Clear? So base, obtuse angle, triangle, height, and parallel lines. Now we will enter to the basic proportionality theorem proof. So basic proportionality theorem. See the theorem statement. Basic proportionality theorem. If a line is drawn parallel to one side of a triangle to intersect the other two sides in distinct points, the other two sides are divided in the same ratio. Okay, this is the statement. This theorem, sometimes they will give the total statement and they will ask you prove. Sometimes simply they will give prove that BPT, BPT theorem, basic proportionality theorem. Or sometimes they may be asked prove the Thales theorem. Thales theorem. If they ask Thales theorem also, you need to write same theorem proof. Either they will give the total statement or they will ask you write and prove that BPT theorem or Thales theorem. Everything the same one. Now, based on this statement, just we will construct one diagram, triangle A, B, C. ABC is a triangle and a line drawn parallel to one side of a triangle. For example, this is the line. This line is drawn parallel to one side of a triangle. So this is the point, it will be D, the D point, and this is E. This is the information they give us. Now we need to prove that the other two sides are divided the same ratio. Okay, clearly we can write here. Given triangle ABC, this point is given, and DE parallel to BC. This point is also mentioned to prove AD by DB AD by DB is equal to AE by EC. AE by EC. So for proving this, so I'm going to use the area of triangle concept. If you want to calculate area, we required the height. So that I'm going to do the construction. So construction. So I'm going to construct a line DG DG, which is perpendicular to AC. Okay, DG DG, which is perpendicular to AC. This is one construction. And again, from E point onwards, from E point to, from E to, like this, some EF. I drawn one more line, perpendicular line. I think this is EF. EF, which is perpendicular to AB. Now, I'm going to join this BE and CD. I'm going to join BE and CD. So everything is clear. Given triangle ABC, DE parallel to BC. So we are going to prove AD by, simply here itself there, AD divided by DB, AE divided by EC. This only we are going to construction. Now, proof. proof. Just only observe what we are going to prove. So from here itself, I'm going to prove the entire theorem. Now your AD by DB. So I'm going to consider AD as a base of the triangle. Now if AD is the base of the triangle, now which triangle will get here? AD is the base. Then shall I take ADE triangle? Shall I take ADE triangle? Yes. Write down the area of ADE triangle. Area of triangle ADE. Area of triangle ADE is equal to half into base into height. Base is, I said no, AD is the base. And what is its height? What is its height? AD is the base. Then height will be from AD to its opposite vertex, E. So it is EF. EF. Similarly, here see the denominator. Denominator, what is there here? dB. Now I want dB as a base. So dB is a base means which triangle we have here? BDE triangle. Correct? Just observe carefully. It is very easy. But any point if you are missing means it should be little bit confusing only. Okay. So BD is the base. So just observe that carefully here. BDE triangle is a obtuse angle triangle. Correct? Obtuse angle triangle. Then how to take the height? Already clearly I explained. So BD we can extend. Okay. Then draw from E to that BD line one perpendicular. Correct? That is nothing but EF only. Now write area of triangle BD is equal to half into BD into EF. EF. Now take these two triangles ratio. Take the ratio of these two triangles. So the ratio of area of the triangle ADE divided by area of the triangle BDE, that is equal to 1 by 2 into AD into EF divided by 1 by 2 into BD into EF. Just we can cancel it here. 1 by 2, 1 by 2, EF, EF. So we'll get AD by AD by BD. This is equation number 1. This is equation number 1. The same way, here what is the this side we have? AE by CE. Just we can observe carefully here also. AE triangle. AE is the base. AE is the base means which triangle will get? AE is the base. If AE is the base, AE is the base, we'll get AED triangle only. No? AED triangle, correct? AE is the base means AED triangle. So AE is the base, then its height will be DG. Height will be DG. Right now, area of AED triangle. Area of triangle AED, that is equal to half into base will be AE, height will be DG. Similarly, another triangle ma AE by EC required. AE by EC. So now EC is the base. EC is the base. If EC is the base, which triangle will get? CED triangle. In CED triangle also, obtuse angle triangle. In obtuse angle triangle, we need to extend the side and draw the perpendicular. So CE is the base, height will be dz. CE is the base, height will be dz right now. Area of CED triangle. Area of CED triangle. So half into base EC into height will be dg. Now take the ratio of these two triangles. Area of triangle AED divided by area of triangle CED is equal to 1 by 2 into AE into DG divided by 1 by 2 into EC into DG. So here also we can cancel 1 by 2, 1 by 2, DG get cancelled. So we'll get AE by EC. This is the second equation. So from equation 1 and equation 2, we can observe AED triangle and ADE triangle. The both will represent the same area only. We are taking the two different bases and their corresponding heights, but within that triangle only. So they are same triangle, equal only, no issues for that. And BDE triangle and CDE triangle. The diagram once observed here, BDE triangle, CDE triangle have the same base DE and between the parallel lines. So already we discussed in that above, they having equal area. Right, that point. That point we can mention. We know that, we know that, we know that hmm, a triangle, we know that triangle BDE and CDE, BDE, CDE having same base, DE, same base DE and between same parallels. They lie between same parallels. Same parallels. So we can conclude that area of triangle BDE is equal to area of triangle CDE. So these two will be equal. So now finally from 1 and 2, from equation 1 and equation 2, we can write AD by DB. AD by DB is equal to AE by EC. This is the basic proportionality theorem. Hence proved. Hence proved. It's a very important question. Definitely they will ask for 5 marks.